Hey everyone, today we are back again with our math class, and today we will start from question number 16 as we have already completed up to question number 15 in my last video. So here in this video I am going to start from question number 16 where true false questions are given. So in the first question it is written 3 by 8 is equal to 15 by 40. You have to check whether this given statement is true or false. So you can understand that these two has to be the equivalent fractions. Okay, and for making any fraction equivalent to another one, we have to either multiply or divide by the same number, the denominator and the numerator both, and we have to get such a fraction like that. So here you can see 3 has become 15, means it has been a multiplication by 5, and 8 has been 40, so it has also become a multiplication by 5. So here the condition of being an equivalent fraction has been satisfied, so we can say that the given statement that 3 by 8 is equal to 15 by 40 is true. Let's come to the next one. Here in the next question it is written 4:7 is equal to 20:35. Here also the same thing we will do, but before doing we have to just convert these two ratios into fraction as I am doing so. You can see. So what will you do? Simply the same procedure, we will check whether these two fractions are equivalent or not. Here from 4 it has become 20, so multiplied by 5. Here from 7 it has become 35, so again multiplied by 5. So this statement is also true that 4:7 this ratio is equal to 20:35 because both of these ratios are also equivalent. Okay, so this statement is also true. Let's come to the next one. So here in question number 18 another ratio is given, that is 0.2:5 is equal to 2:0.5. So here also we have to do the same thing. Simply first we will convert these ratios into fraction. Here I am doing so. Yes, you can see this. See, here you have to understand one thing. Without doing any calculation, you can understand whether these two are equal or not. See here from 0.2 it has become 2, means it has been increased. And here from 5 it has become 0.5, means it has been decreased. Okay, so it cannot be possible in finding an equivalent fraction. If the numerator is increasing, then the denominator must be increasing, and if the numerator is decreasing, the denominator will also decrease. Okay, so here the logic is not satisfied. Okay, so without doing any calculation we have come to know that these two are not equal or equivalent. Okay, so this statement, question number 18, is false. Let's come to the next one. In question number 19 it is written 3:33 is equal to 33:333. Okay, now again same procedure, we will simply convert them into fraction. Okay, after converting them into fraction we will check whether the numerators are increasing and denominators are also increasing, and whether both of them are decreasing or not. So what will you do for this? Here 3 has become 33 in the next numerator, so it has been a multiplication by 11. So we must have to multiply this 33 by 11 for getting these two ratios equal. If we multiply 33 and 11, we will get 363, which is not equal to this. Okay, so this statement is also not true. It looks like that it must be true, but it is not true. Okay, so whenever you are multiplying 33 and 11, it will not become 333. Let's come to the next one. In question number 20 it is written 15 meter is to 40 meter is equal to 35 meter. is to 65 meter. Now again the same thing we have to check. Let's simply convert it to fractions. Now you can see that both of these fractions are not in their simplest form, so it will be better if you just convert them to their simplest form. So here I am reducing it by 5, so it is coming 3 by 8. On here also we are doing the same thing. We are just reducing it by 5 and we are getting 7 by 13. And here from this calculation we can get that these two ratios are not equal. Okay, so this statement is not true. Let's come to the next sum. Question number 21, the same thing. 27, I'm not writing the units because here in the ratio the units are not required, so I'm simply converting this 27 is to 57 in its ratio and 18 by 38. Now again simply we will reduce them because both of these are not in their simplest form. I'm reducing them by 3 and here I would like to reduce it by 2. So both of these fractions are coming same, 9 by 19 and here also 9 by 19. Okay, so see here in this statement both of the fractions are coming 9 by 19, so it is coming true. Let's come to the next sum. Now here in this sum, question number 22, simply we will just convert these ratios to fraction. Okay, we have converted. Now what would you do? First we will check the numerators. 5 has become 7.5, it has been increased. Now 7.5 has become 5 in case of denominator, so it has been decreased. So this is not the exact condition of being equivalent fraction, because if multiplication is done then both the numerators and the denominators will increase. Okay, so here in this case we will simply do this statement false because these are not satisfying the actual condition of being equivalent fraction. Now let's come to the next sum. Here in the next sum it is written 20 gram is to 100 gram is equal to 1 meter is to 500 centimeter. Now see, I am just converting both the ratios into fraction. 20 is to 100 is coming for the first one, and second one 1 meter is to 500 centimeter. It will be better if you simply convert this 1 meter into centimeter, because both the terms of the ratios must be in the same unit. So here after converting 1 meter into centimeter I am getting 100 and the fraction is coming 100 by 500. Now here you can see I am just simply reducing these fractions and I am getting 1 by 5 in both the cases. So this given statement is true, that is 20 gram is to 100 gram is equivalent to 1 meter is to 500 centimeter. It may be possible that the units are different, but when we are finding the ratio properly or when we are converting it to a fraction, we are converting both the terms in a single unit. So this given statement is true. Let's come to the next one. In the next sum, question number 24, the same thing is given. Here 12 hours is to 30 hours. See, I am not writing the ratio, simply I am converting them to fraction. Now 8 kilometer to 20 kilometer. Okay, now simply we will reduce them. First one is coming 2 by 5. Second one is also coming 2 by 5. Okay, we have reduced it by 4 and we have reduced it by 6. Okay, so see here we are getting both the fractions equal, so this statement is also true. Let's come to the next sum. Now in the next sum it is written the ratio of 10 kg to 100 kg is 1:10. Now let's write 10 kg to 100 kg. What is coming? 1 by 10. Instead of 1 by 10 we can write 1:10. So this given statement number 25 is also correct, so we are writing it true. Let's come to the next sum. In question number 26, it is written the ratio of 150 centimeter to 1 meter. 150 centimeter to 1 meter. So instead of 1 meter, simply we are writing it here 100 centimeter, because both of these terms must be there in their same unit. So 150 centimeter to 100 centimeter. Now simply we can just reduce this fraction and we are getting 15 by 10, and here in the ratio it is given 1 by 1.5. okay, so just after converting it to fraction we can get 10 by 15. okay, how it is coming I'm showing you in the next video, but here it will come 10 is to 15. okay, so here from 15 we are getting 10, here from 10 we are getting 15. Again the logic is not applied here, so this statement is not true. Let's come to the next sum. In question number 27, the same thing is given 25 by 20. Here it is given 25 kg is to 20 gram. So 20 gram will be converted to kg, or it will be better if you simply convert 20 kg into gram. So simply we are multiplying it by 1000. okay, in the next part it is given 50 kg by 40 gram. So it will be better if you simply convert that 50 kg to gram. Here I have done so. okay, now you can see 50,000 25,000 has become 50,000, 20 has become 40. So we don't need to even reduce it. We can understand that both of these are multiplication by 2. okay, now see, this given statement is again true. Let's come to the next sum. But keep it in your mind, you have to check the units properly, whether they are in same unit or not. If they are given in same unit, then it's okay. If they are not given in same unit, don't forget to convert the units properly. okay, let's come to the next sum. Question number 28, it is written the ratio of 1 hour to 1 day. 1 hour to 1 day. Now see, 1 hour means I'm just writing it here 1, I'm just converting it to the smaller unit, and 1 day means 24 hours. So in the ratio if we convert it we will get 1 is to 24. Here instead of 1 is to 24 it is given 1 is to 1. So this statement is false. Let's come to the next sum. In question number 29 it is written the ratio 4 is to 16 is in its lowest form. Of course not. 4 is an even number, 16 is also an even number. So this statement is also false. Let's come to the next one. The ratio of 5 is to 4 is different from the ratio 4 is to 5. Of course that 5 is to 4 means 5 by 4. 4 is to 5 means 4 by 5. Of course both of these are not same, because this is an improper fraction and this is a proper fraction. If we check it in this way we can understand this. Here from 5 we have got 4, from 4 we have got 5, means again the logic of being equivalent ratio or fraction is not satisfied. So this is not true. So both of these fractions or the ratios are not same, and this given statement is true. Let's come to the next sum. Question number 31, it is written the ratio will always be more than 1. See, 3 is to 5 is also a ratio. If we convert it to fraction we will get 3 by 5, which is a proper fraction and less than 1. So this statement is also not true. Let's come to question number 32. In question number 32 it is written the ratio can be equal to 1. Yes, it may be possible, because if you just simply take 5 is to 5, it is coming 1 is to 1. So in total it is coming 1. It may be possible that both the terms are coming same, but it is not possible that always it will be more than 1. It might be less than 1. Okay, so this statement is true, because here can be is written. If it is written always 1, then it would have been a false statement. Now let's come to question number 33. If B is to A is equal to C is to D, then A, B, C, D are in proportion. Now see, here for being a proportion, we have to check whether the last two terms, the product of the last two terms, means the extreme terms, are becoming equal to the product of the middle terms or not. So here A, B, C, D are in proportion given. A, B, C, D. So here the last two terms are coming A and D. So their product must be equal to the product of the middle two terms, means B and C. So here it is coming AD is equal to BC. Okay, if this statement satisfies in this case, then we can say that ABCD are in proportion. But if we cross multiply these two, we will get BD is equal to AC. And here the statement has become AD is equal to BC. Both of these statements are not equal. So ABCD are in proportion. This statement is not true in question number 33. Okay, let's come to the next sum. Question number 34, it is written that two terms of a ratio can be in two different units. Yes, the two terms of a ratio can be in two different units. See, here it might be written in this way, but whenever we are doing the sum, it must be converted to a single unit. Otherwise, it will not be a ratio. Okay, so this statement is false. So today after this class, in my next video, we will start another sums from the chapter algebra or the chapter ratio and proportion. Till then, keep studying, keep practicing, and stay safe. Bye everyone.